Okay, so we'll do the application just like I said, and then we'll route in the form y equal to k e raised to the power mx plus a and y equal to ln ax plus b. We do all these kind of sketches. My GeoGebra app as well, so that this becomes easy for you to understand. Now, the application is no different from the solving of the questions. It's just the same thing. This time we are applying the logarithm to real life problems. And as a science student, you come across this a lot. One application you can use logarithm for is going to be for growth, population. And there is one major thing that I think if you've got in your mind, it will make your solving process easy. As we go on, I'll give you some pointers as well. Now, anytime you come across the word initial, what does it mean?
Like it means like ooh, like that's the normal standard.
Normal
Like
standard? I don't really think so. Try again. If I tell you that initial,
beginning or something.
come again.
Beginning.
Okay, beginning. I'll take the beginning. Okay. So if let's say you are going to start a race, right?
Yeah.
So answer on the mark, whatever they say, and at that point, when you start racing, the time starts going, right? So that the time
Yeah.
you see like how long it took you to complete the race to get to the finish line. So if you're at this point, the beginning, just like you said, initial is the beginning. What is the time over there?
0 seconds.
0 seconds, because you've not started the race, right? So we
Yeah.
should note that anytime you come across the word initial and we are dealing with days, time, whatever thing we are doing, it means that we are now starting from the beginning. So that is the time is equal to 0. Are we good?
Yeah.
So the time is equal to 0, and that is something you have to keep in mind. Can I continue?
Yes, sir.
Okay. So in this question, we're told that the population P of a certain bacterium T days after the start of an experiment is modeled by P is equal to 800 E raised to the power KT, where K is a constant. What the figure 800 represents in the experiment. Okay, so this will take us some observation to do, then we'll do a generalization. We're told that P is equal to 800 E raised to the power KT, right?
Yeah.
Let's see what happens when T is equal to 0. So this gives you P equal to 800 E raised to the power K times 0, which is the same as me saying that P is equal to 800 E raised to the power 0, because any number times 0 is 0. Okay?
Yeah.
Then E raised to the power 0, any number apart from 0 raised to the power 0 is equal to
One.
1. So this basically P equal to E raised to the power. Sorry, this times 1. And P is equal to 800. We've gotten the P over there to be 800. But how did we get a P to be 800? That was when T was equal to 0. And I just said something. When T is equal to 0, what does it represent?
The initial.
So the initial position. So in this case, we are talking about population. So you can say that the 800 represents initial population. Is that okay?
Yeah.
So you can, okay, I don't know if you are going to jot this one down, but that is that. So the 800 represents the initial population. So maybe one day if you come across, let's say the population is given by 400 e raised to the power 5t. What's the initial population?
400.
So P is equal to 300 e raised to the power 3t minus 10. What was the initial population?
290.
The 290. I thought you said 300. So this will give you 300 is equal to 0 minus 10, and this equals to 290. So initial population is going to be 290. So for you to find the initial of anything, you should know that the time is equal to 0. We good?
Yeah.
Great. So we're told that given that the population 20,000 2 days after the start of the experiment, calculate the value of k. So we're given a condition where the population was given to be 20,000, and we're given the time to, the time was 2 days,
Is it okay for this thing?
and we have to
Citizen
calculate the value of k.
is
So p in this of is equal to 20,000, then p is equal to p. Okay?
yeah.
Okay. So we can substitute this one into the equation. So we've got p equal to 800 e raised to the power kt. We're given the parameters where p is equal to 20,000. Then 800, then e raised to the power t was given as 2, so 2k. So basically you have to find k in this, and this leads us to an exponential question. So I can divide this one by 800, then this is paper 1, so you're not supposed to use a calculator. But 200 divided by 8, let's use a calculator. Okay, so 200 divided by 8, that's 25. So 25 equal to e raised to the power 2k. Then from there, we should be able to continue from here to find k. We give?
Yeah.
Okay, so let's do that and let's see what we get.
Hello, sir.
Yeah.
I already sent the ID, and can you please send me the number of the
Use your, okay.
Say x is equal to 0.81 or 82.
X. Using x.
Hey, key. Sorry.
Okay. Okay, so let's see how you got that one.
So I put it in the calculator.
Oh, serious. So how would you solve this one?
So should I change it to logarithm?
How would you solve it?
Okay. So I'll change it to logarithm, which
Okay,
is
so
log e.
log e.
Log 25 is equal to 2k.
So basically then 25 is equal to 2k. Then k is equal to 1 over 2 lane 25. Is that okay?
Yeah.
Okay, so k is equal to lane 25 raised to the power 1 over 2. Do you agree to that one too? Do you agree to that?
Say please.
Do you agree to that?
Yes, please.
Then k is equal to lane 5. Okay, so I told you the last time that as a science student, you try as much as possible to avoid approximation. So yeah, k is equal to lane 5. Okay?
Yeah.
Okay, so from there, we can rewrite our equation. So our equation will be P is equal to 600 E lane 5, since K is lane 5. Can I continue?
Yes, please.
Calculate the population 3 days after the start of the experiment. So in this case, the parameter given was that T is equal to 3. So P is going to be 800 E raised to the power 3 lane 5. Then P is equal to 800 E raised to the power lane 5 raised to the power 3. And P is equal to 800 E raised to the power lane 5 raised to the power 3 should be 125 if I'm not
Yeah,
mistaken.
125.
Then I taught you something that once you've got E and the lane, it cancels out. So P is
Yes.
equal to 800 multiplying 125. And let me use a calculator for this. 800 multiplying 125. There's going to be
925. Huh?
9, I should say
Hey, sorry.
100,000.
Eh,
Let me confirm using the calculator. So
say 800.
800 E raised to the power 3 lane 5, and this would be equal to 100,000. Good. Pretty good.
Yeah.
Okay, so this one we solved this in the first lesson. Okay, so try to do this one and see if you can do it by yourself. Then we'll continue with the other ones.
Sure. Say please, I'm done.
Okay, so walk me through what you did.
The first one, I got 1,000.
Okay, that is the initial, so B is equal to 1,000.
The second one, I got T to be falling to.
Okay, how did you do that one?
So then they said find time taken for B to double in size.
Okay,
Then I just doubled B. So it became 2,000
okay,
equal to 1,000 e raised to the power T over 4. Divided both sides by 1,000. Yeah. Change them to, yes,
what did you say your answer was again?
falling to.
Okay, oh, you can say that is the same as writing lane 2,
Then 2 raised to the power 4.
which is lane 16.
Yeah.
So lane 16 hours since T is in hours. Okay, is that okay?
Yes, sir.
Okay, the next one, find B when T is equal to 8. I think that one is easy. We just substitute T for 8.
Yeah.
So B is going to be equal to 1,000 E raised to the power
2.
8 over 4. Okay, 2. So yeah, you can leave the answer that way so that you don't approximate. Okay.
Yes, sir.
Okay. So attempt this one too.
Sure. So I can go to the second question.
What do you get for the first one?
1,000.
1,000. So initial. Okay. So why did they leave a lot of space like that?
That's all.
Yeah, I think there is a follow-up question, but they didn't bring it. The person forgot. Maybe.
Yeah.
Because for one mark for a full page, it doesn't make sense. Because he didn't really do anything. He substituted t equal to 0 then. You can
Yeah.
literally see the answer without working. Okay. I think we've done this one already.
Yeah.
This one was repeated. So let's see this one. Let me write something so I know. So this one, so b is equal to 200 e raised to the power 2 of 0. That's 800 e raised to the power negative 2 of 0. And this equal to 1,000.
So please, I'm coming right now.
Okay.
Be right back.
Loyal.
Yes, sir.
Okay. Yeah. Yeah, I think you've done this one too. So this one has been solved. 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 Yeah. So we've solved all the questions in paper one. Let me see. Let's do the paper two. You save this one, then we do the paper two. I think we solved this question, right? No, we didn't solve this one because of the expansion of
Yeah.
we didn't solve.
Yes.
20. So
We solved this one. Yes.
and this one too, I think so.
Yeah, I solved this.
Okay, let's see if we can do this one.
Okay.
So the number b of bacteria in a sample is given by b is equals to p plus q e raised to the power 2t, where p and q are constant and t is time in week. Initially, there are 500 bacteria, which increases to 600 after 1 week. Find the value of p and q.
So I just solved it.
Yes, please. Attempt it.
Okay. All right. Say I don't know. It's not. It's not coming.
Okay. Anytime you come across two variables to be found, you should be thinking about simultaneous equation. Okay.
Mm.
Now they give you a lot of conditions.
Yeah.
First, you're told that initially there are 500 bacteria over there. So, how can you rewrite this one?
Mm.
I just told you something that initial represents t to be equal to what? Initial represents t to be equal to
Beginning start.
zero. So when t is equal to zero, the bacteria will got 500. So that's the first condition. Now the next condition gives you this one, 600, 1 week. So when t is equal to 1, b is equal to 600. Is that okay? Is that okay?
Yes.
So let's work with the first one. T equals to 0, b equals 600.
Yes, please.
500. So 500 is equal to e plus q, e raised to the power 2 of 0. But you should have noticed this equation straight away. Because initial, so p plus,
Yes, I,
you got this one. Got this one?
yes.
Okay. The next one.
Yes,
The next one when
600 equal to P plus
so 600 is equal to p plus
P
q
plus Q E raised to the power.
2. Is that okay?
Yes, please.
So I can subtract the two equations. So equation 1 minus equation 2 so that the p is eliminated. You know the elimination rule method, right?
Mm.
Okay, so this negative 600, sorry, negative 100 equal to q minus q e raised to the power 2. Can I continue?
Yes, please.
So negative 100 equal to q out 1 minus e raised to the power 2. Then q is equal to negative 100 over 1 minus e raised to the power 2. Or if you like, you can say that q is equal to 100 over e raised to the power 2 minus 1.
Mm.
Is that okay?
Yes, please.
Okay. Let's use the mouse. Let's use the mouse. Okay. Let's continue that way. Then you can find p. You can find p by putting this into equation 1. So equation 1 says that 500 is equal to p plus q. So this will give you 500. It's p, which is we don't know, plus q 100 over e squared minus 1. So p is equal to 500 minus 100 over e squared minus 1. Is that okay?
Yes, please.
The exact way is becoming too complicated. So, but this one you can just type on the calculator. Don't worry yourself. Okay.
Mm.
Okay. So there's 500 e squared minus 600 over e squared minus 1. So that's the value of link key. Oh, let's type this on the calculator. I don't like the way it's looking.
15.65.
That's for Q. 15.65.
Yes. 654.
Yeah. And the P.
Okay. 484.35.
What is what?
484.35.
I doubt it. He said this one was 15.65.
Mm.
Oh, okay. 484. I was doing 16 instead. So 484.65. Okay, so let's
I said 0.35.
0.35. What is wrong with me today? Okay, so we can rewrite the equation for the bacteria. B is equal to P So B is equal to 484.35 plus 15.65 e raised to the power. How we get?
Yes, sir.
Find the number of bacteria present after 2 weeks. Now we have this one. You can quickly find the number of bacteria after 2 weeks by substituting T for 2. So anywhere you see T, you put 2. Okay? How we get?
Yes, please.
Okay. So B is equal to that.
Say.
Yeah, I said B is equal to that. So we get me the answer to the question.
Yeah. So you get 1,338.
Okay, so 1,358.
38.
Okay. Um,
0.81.
0.81.
Yeah.
Find the first week in which the number of bacteria is greater than 10,000, 1 million. So the number of
Yeah.
bacteria is greater than 10,000. So there's the number of bacteria. This is greater than 1 million, sorry. Greater than 1 million. So we should be able to solve this one. Move this to the other side, divide by 15, then solve for that e raised to the power 2t is greater than. So 1 million, I get it, minus 484.35 divided by 15.65. That's then. So there's 63866. I think 8147. Okay, so if you take lane of both sides, you get 2 raised to the power t greater than lane 63866.8147. So let me take lane of the answer, then divide by 2. So t is greater than, so the number of weeks should be greater than 5.532. So the first week that should be greater than this will be when t is equal to 6. Okay?
Yes, please. We would.
Okay, so you can jot this one down.
Say please on them.
Okay, great. I think we solved this one too. And this indices.
So,
And this one too. Divide both sides by u raised to power x. You solved this one, right?
yeah.
What of the simultaneous equation?
Yeah, we solved it. We said we should make log 2x a log x base to a different variable and log y base to a different variable.
That is not what we said. It is a little bit different.
This is different from that one.
There's different. Don't use a calculator for this one. Try this one. So group all the logs at one side.
Wait, say I'm just supposed to solve the cubic expression.
No. You have to show that. How did you get a cubic expression? That's what they're asking you.
No. And so then I'm solving it all.
No. Okay, let's do this together. We are solving the logarithmic what's the name? Simultaneous equation. We're solving this one.
Yes.
But by solving this one, we're told to show that this is equal to that. Okay, so let's do this. Okay, mess it up. Okay, with this one, the rules of logarithm still apply. Remember what I told you when you're dealing with log equation, make sure you get rid of the number in front of the log and group all the logs at one side of the equation. So this thing will be written as 3 minus log x squared. Do you agree?
Yes, please.
Okay, so we've got log y plus 1 base 2 is equal to 3 minus log x squared base 2. Grouping all the logs at one side, you get log y plus 1 base 2 plus log x squared base 2 equals to 3. Then you got log x squared y plus 1 base 2 equals to 3. Then changing from logarithm to exponential, what will this one be?
2 raised to the power 3 is equal to x squared y plus 1.
2 raised to the power 3. 2 raised to the power 3 is 8. So 8 is equal to x squared y plus 1. Let's call this one equation 1. You get?
Yes, please.
Then we take the other parts of the equation and work with. So the other parts of the equation, we have this one to be log x plus 2 base 2 equals to 2 plus log y base 2. Grouping all the logs at one side, since there is no number in front of the log, we get log x plus 2 base 2 minus log y base 2 equals to 2. This is the same as writing log x plus 2 over y base 2 equal to 2. How we get with this?
Yes, please.
Okay.
Yes, please.
Okay, so how would you continue from here?
So I'm done.
Yeah, done. Okay.
Yeah.
Okay, good. So those
Is it y is 0 and x is minus 2?
no, if not, you are not done. No. Did we show that?
No, like, yeah, I mean,
we're able to show this?
now, is it?
They never said you should solve the equation. No, they said you should show that x cubed plus 6x squared minus 32 equals to 0. So that's what I'm going to show. So you are not done. You are solving the equation. The solving part will be the second part. So that's
No, not this one. I mean, I solved the logarithm, like the logarithm.
yeah.
Yeah.
That's this equation when we are solving. No, then you've not shown anything. Because the first part didn't tell you to solve. It said show that x cubed plus 6x squared minus 32 equal to 0. And the next part of the question says that solve or find the roots of that. So what you've done is the B part of the question, not the A part of the question. So the A part of the question, I'm trying to solve the thing like the way we solve equations. So I did the first one in the red, and I'm doing the second one in the blue. So if you are to change this one to exponential, this becomes 2 raised to the power 2, which is 4, is equal to x plus 2 over y. This is equation 2. I can make y the subject of equation 2. So make
make x the subject of equation 2.
If I make x a subject, I'm going to get this one in terms of y. We're told to find So I'm going to make y the sub here so that I get rid of y. We'll make y the sub of equation 2. I think it will be easier to make y the sub of equation 2. So from equation 2, this will give you 4y is equal to x plus 2. Agreed?
Yeah.
Then y will be equal to x plus 2 over 4. That's okay. It's making y the subject okay over here. I made y the subject
Yes.
of the equation. Okay, so
Yeah.
from here, we can now put this one into the untouched equation. So put y is equal to x plus 2 over 4 into equation 1. So this will give you 8 equals to x squared. Y is now x plus 2 over 4 plus 1. So from here, I can say that is the same as writing 8 is equal to x times x squared will be x cubed plus 2x squared all over 4, then plus x squared. Is that okay?
Yes, please.
Okay, so get rid of the denominator by multiplying everything by 4. So this one by 4, this one by 4, and this one by 4. This will give you 32. 4 8 is 32. Equal to, this 4 will cancel out this, leaving you with x cubed plus 2x squared. Then the 4 times this will give you 4. So if you simplify the left hand side, the right hand side, that will give you x cubed plus 6x squared. Now moving the 32 to the other side, you get x cubed plus 6x squared minus 32 equals 0. So this is what we're told to show.
Okay.
So x cubed plus 6x squared minus 32 equals 0. So this will give you the 4 marks, not what you did.
See, you see that my problem was I made this
X
thing
plus
X the subject, yeah,
Because
and I
you're not
just
looking at the proof. The question said you should show that x cubed plus 6x squared minus 2 minus 32 equals to 0. And we are doing in terms of y. So you'd have gotten it wrong. You'd have gotten like 2 out of 4 marks, which is not, it's not good.
okay.
When you can literally get all the marks. So getting half of it is not good at all. Can I continue?
Yes, please.
Okay, so you should be able to solve the cubic equation from polynomials. We did this from polynomials. Right?
Yes, please.
What are the factors of 32? Let me just use the calculator quickly, but I will solve it. So 1, 6, 0, negative 32. So we know we've got 2, negative 4, and 2, negative 4. So I can say that f of 2 equal to 2 cubed plus 6 of 2 squared minus 32 equals 0. So since f of 2 equals 0, what can I say?
X minus 2 is a factor.
Yes, a factor. The factor of,
X cubed plus 6x squared minus 32.
let's say, f of x, so that we don't write it.
Yeah.
So we now perform the long division, or if you like, now do the comparison method. So this is going to be x cubed plus 6x squared plus 0x. And we've got this one to be x minus 2. So I didn't teach you the synthetic method of division, right?
This method or
Synthetic, where we use the coefficients. So
no.
okay, I'll teach you later. Okay, so this will be x squared. Let me do the division quickly. Then we don't really have time because I have to do another thing with you. So x cubed plus x squared. Just warning your dog like that. Okay, so I'm doing the division quickly so that we move on. No, actually, you should do the division for me. So, I got this one to be x squared plus 16x plus 8x, sorry, plus 16.
Yeah, that's what I also got.
So we got x minus 2. And this turns out to be x plus 4 all squared. I don't know if you've noticed.
Yeah.
Okay. So x minus 2 equals to 0. X plus 4 all squared equals to 0. So x equals to 2 and x equals to negative 4. And that will answer the question. Are we good?
Yes, please.
Oh, we are not done. Okay, so give a reason why only one root is valid solution for the logarithm equation, and find the value of the value of y corresponding to this root. So we're told that okay, even though we've gotten two answers, one of them is correct and one of them is not. So give the reason why one is not. We got the answers to be 2 and negative 4. So what is the reason? Which answer is not correct?
-4.
The negative 4. Why? But it says you
Because when you put -4 where x is, you not get 0.
don't get no, that is not true. You get 0. Actually, if you put negative 4 over there, you get 0.
Yeah.
Negative 4 is not the answer. That is the first part of the question. Yeah, negative 4 is not going to be selected. The reason is the domain. Come on, we've said this several times. The domain, the logarithm can take negative numbers.
Yeah.
So if you plug the negative 4 over here, you're going to get negative 4 plus 2, which is negative 2. And this is also going to give you negative 4. This is going to disrupt the domain of logarithm. So logarithm doesn't take 0. Okay? Actually, what did I say about the domain of logarithm?
That you can't get a negative
So what is
number.
so if log a base b, the domain will be that a is what?
Greater than 0.
A is greater than 0. Okay. At least for this one. Okay. So the reason is that it's going to make the logarithm contain a negative number, which will be out of the domain of the logarithm log function. So we now know the value of y, the x. We can now find the value of y. So x equals to 2. We can find the value of y. I can put this into any of the equation. Which equation should I take? Yeah, let me take this one. So x equals to 2, we place into that to find the value of y. So this will give you, oh, that was the wrong equation to pick anyway. Okay, so this gives you 2 for this one. So 4 is equal to 4 y, then over 1 over 1, so y is equal to 1.
Yeah.
Is that okay?
Yes, please.
So that will answer the question as well. Okay, so that's the end of the log equations and the
Application.